Okay, notes 3 is calculator commands and follow-up analysis. So a lot of these notes we're going to end up crossing out because it has to do with the TI-84. And I'm going to write you the steps on Desmos. So this note is going to be pretty much a refresher from notes 1 and notes 2. So it's combining those first two notes and seeing if you know how to find the difference between a chi-squared goodness of fit and a chi-squared of homogeneity. So the first thing I want you to cross out is this whole part right here. Okay, when they're asking you to solve for chi-squared on the TI calculator, whether that is 84 or Inspire, they have you go through a lot of steps. Since we have Desmos, we don't have to go through all those steps. We just need to remember that we can find both chi-squareds under inference and categorical data. Okay, so if we go on to Desmos, we hit the plus sign, inference, categorical data. There is both our chi-squared for independence, which is homogeneity, and chi-squared goodness of fit. So both of them are there. Okay, so let's look at example 1. So you'll notice that these first couple examples are from the notes. So we've already done these problems. It's just showing you the difference between the two tests. So example 1 says the mice from notes 1. Remember that problem talked about the different eye color for the mice. It had observed values and it expected values. It says, what are the chi-squared statistics and p-value? So since this one gives you both observed and expected, and it's only one category, that's how I know that this is going to be chi-squared goodness of fit. Okay, so on my calculator, I'm going to go to chi-squared goodness of fit, and I'm going to type in all my observed values and the expected values on the table. And remember, everyone should have Desmos open. We should be following along because our test is a week from today. Correct. And also the fact that this is just talking about one categorical data, which is just color of eyes. Okay, so once you type in all the observed and expected, hit on create tests. And if you drop down on significance test, notice that there is your chi-squared value and your p-value. So chi-squared is 9.719 and our p-value is 0.021. Okay, so again, since we only had one category, and that was eye color, and we're given observed and expected, that's how I knew it was chi-squared goodness of fit. Okay, right here, that next line under it, cross that out. That is talking about how to find contribution on the TI. On Desmos, if we just go to the top here, do you see where it says observed and then in parentheses it says expected? If you click on this drop down and then you put a check mark where it says contributions, it's going to open up another tab on our table and it's going to give us all the contributions for our data. And what's important about these contributions is that if we were to add up all the contributions, we would get chi-squared or chi-squared statistic. So I want you to just make a note that you will find this on the observed tab, and then you need to check contributions. Okay, it's not automatically checked on Desmos. You have to check it. Okay. Again, what is important about these contributions is, if you recall, chi-squared talks about the summation of all contributions. So the summation of observed minus expected squared divided by expected. Okay, the same thing that we learned when we did the M&M lab. Okay. This is important because it helps us determine which proportion was the most different than expected. So this helps us determine which proportion was the most different than expected. So the higher the contribution, the more it differs from what we originally expected. Okay. So example 2 was the notes that we did yesterday, and it was the living arrangements versus male and female. So notice here that we have 2 categories. Okay. We have the category of where they live, and then we have the category of what their gender is. So since this is 2 categories, and the table is only the observed values, we know that this is going to be chi-squared for what? Independence or homogeneity? Homogeneity. Remember, the name of the inference is homogeneity. Where you go on Desmos is independence. Okay, because what we're going to learn in the next notes is that independence, association, and homogeneity all use the same formulas. That's why you find it on the same place on Desmos. Okay, so I'm going to go to add an inference. I'm going to click on chi-squared test for independence. And I'm going to make sure that I type in only my data. Does that mean I include the totals? No, I do not include the totals. So only write these 6 numbers here. Okay, not the totals. Okay, so 61, 60, 29, 27. And then also make sure that if we have more than one category, that you are putting this into different columns, right? So we have the column with parents, the column with apartment, and the column with dorms. Okay, I only say that because on the homework I was seeing from last period, was seeing some mistakes where they were trying to put them all in one column. Okay, for one, you'll notice that you're going to mess up your data, and another fact is if you have more than 8 numbers, Desmos only lets you go up to 8, okay, which means you're not ever going to have that many to put on to Desmos on this exam or the AP exam. Okay, so I hit create test, and if I go down to significance test, I should see my chi-squared value. So chi-squared is 9.365, and then I see my p-value, which is 0.009. And then, of course, I can click on those 3 dots, and I can get a more precise depiction of those decimals. So if I wanted to add more decimals to my p-value, that's where I would find them. And that's what we did on the last notes, where we said it was 0.00926. Okay, so that was recap from notes 1 and notes 2. Any questions so far? Okay. So now we're going to talk about follow-up analysis. So what's important about this is on some of your multiple choice and or FRQ questions, since they are not able to know what calculator you're using, right? Some of you are using Desmos. Let's say some schools are using the TI. Some schools are doing everything by hand, okay? Well, since everyone is doing something different, they actually will give you a computer output, and you have to be able to read this output to answer some questions. So the main thing here is to pay attention to the key. So notice off to the side it says key, and then it says observed, expected, and then that means contributed. Okay? Which means the first number in this computer output is your observed values. Okay, so I'm just going to color code it to help me with the notes. The second number there is our expected values. And the third number there is your contributions. Okay. Also on the computer output, you get your chi-squared number. Okay, so typically they will write out the word chi-squared. Just know that this is chi-squared, degrees of freedom, and the p-value. Those two are self-explanatory. Okay. So typically they'll say, looking at this computer output, they're going to ask you about the contributions. So the contributions here are what I highlighted in blue. And they're going to ask you pretty much which ones have the highest contribution. So looking at our computer output, which two have the highest? Good. Dorms for both male and female. So notice that our chi-squared value is 9.365. Well, if we were to add up these contributions here, just these two out of the 6 data points already make up half of our chi-squared value. What this tells us is that these proportions, so the proportion of females and the proportion of males living in the dorm is greater than what we expected. Okay. Next part of the notes tells us, okay, let's see if we can identify the difference between the two chi-squareds and the two proportion z tests because they're all very similar. So the first one here is the 2-sample z-test for proportions. Okay. Allows us to test the null hypothesis, P1 equal to P2, where P1 and P2 are the actual proportion of successes for the two populations. So, the big thing that sets this test apart from the other chi-squareds is that we're only looking at two populations. Okay? The chi-squareds look at several populations. Okay, then the next one is chi-squared goodness of fit. So chi-squared goodness of fit test allows us to test the null hypothesis. So where P1 is equal to P2 equal to P sub K, right? As many proportions as we want. We're no longer restricted to two proportions. This null hypothesis says that there is no difference in the proportion of successes for K populations. This is for a single categorical variable across many populations. Okay, so it only deals with one categorical variable, but it covers many populations, and that we're saying that there's no difference in several proportions, not just two. Then we have chi-squared for homogeneity. And this allows to test the null hypothesis for multiple categorical variables across many populations. Okay, remember this data is most likely displayed in a two-way table. So when you're reading the problems, you're going to be looking for that information that I highlighted to determine what type of test you're doing. Okay, of course, in these notes, we know that we're only working with chi-squared because this unit is on chi-squared. But once we look at the AP exam, they're not going to be broken apart into sections, so you're going to have to be able to identify the inference on your own. Okay, so let's look at an example. It says a college professor at a large university conducts a study to determine which of the big 5 personality traits a person displays the most of. He took 3 separate random samples of college majors and recorded the personality trait of each individual. The results are shown in the table. Okay, so we have all our results. Remember, the important thing about these results is everything but the totals. And these values are what? Observed or expected values? Observed. Okay, because this is based off of his simulation. Okay. These 3 questions at the bottom are usually the questions added at the end of that example question that determines which inference you're going to use. Notice that the last 2 questions say difference in the distribution. Difference in the distribution. Okay? This tells you right away that these are chi-squared. And then depending on him, how many categorical variables they talk about is whether it's goodness of fit, or homogeneity. So this first one talks about business majors, so that's one categorical variable. And then this one says across certain college majors, which is multiple categorical variables, which means that this first one is chi-squared. What? Which one? Goodness of fit or homogeneity? Goodness of fit. And the second one is homogeneity. Okay, which means this first one is going to be 2 sample z-tests for 2 proportions because it's talking about the difference between 2 things, 2 populations. So the difference between 2 populations, not the difference in the distribution, but just the difference in the 2. And that is, again, a 2 proportion z-test. Okay. So different ways you could see the problem. Okay, the first question here says, let's perform a chi-square test for homogeneity. So it tells you right away what it wants you to do. It says to find the null and alternative hypotheses. Okay, so think back to your notes from yesterday, since that's when we did homogeneity. When we write these hypotheses, we're always going to write a what? A sentence, right? We're going to write a sentence. We're not writing it in symbols. And we always say that the null hypothesis is what? There is no difference. There is no difference. So I'm going to write there is no difference in the distribution. And then we start talking about what the problem is. And this is personality types across majors. Which means my alternative hypothesis is going to say what? There is a difference. ... Just because I'm running out of room, do we abbreviate when we're doing the FRQ on a test? No, you're going to write everything down. Just know that everything after that is the same. So there is a difference in the distribution personality types across majors. Okay, then it says use your calculator and find the expected count in the table below. So since we are doing a chi-squared of homogeneity, I am going to go to inference and click on which one? Independence. And I'm going to type in all my values from the observed table. Do I include totals? No. So go ahead and type everything in. Everyone should have their Chromebooks open. Everyone should be working on Desmos. Okay, so once you put in all of those data points, okay, not including the totals, then you're going to hit create tests. And since we want the expected counts, we're going to click on the first drop down where it says observed. And remember, all the numbers that are in parentheses are what? The expected count. So all the numbers that are in parentheses, we're going to write that on our table here. Remember, the only time you'll have to use the formula and calculate this by hand is on a multiple choice question. Okay, or there is a question on your homework that states, show your work how you found the expected value of this and this, okay? Meaning you're going to have to actually show the handwritten work, not the Desmos steps, the handwritten work on how to find just one of those expected values, just to show that you understand how the formula works. Okay, did everyone get those same numbers? Okay. So ultimately what we just did on part A and part B was our communicate. Okay, our first C. Okay, we always do the hypotheses and the expected counts table. On part C, it says, are the conditions met to perform the inference? Are we going to put yes? No. We're going to prove all three conditions. So what's the first one? Random. Okay, does the problem mention about these samples being random? Okay, and what specifically does it state? Good. 3 separate random samples. Remember, whatever the problem states, go ahead and write that. 3 separate random samples. Okay, then we have independence where we check the 10% condition. And since we don't have a sample size here, what number are we using for 10% condition? The table's total. And what's the table's total? 440. So we say 440 is less than or equal to 10% of what? Okay, all people in the university, or you can say all college students. Just make sure you emphasize that we're talking about college. You can't just say all students, because then you're including high school students in there, when really we just looked at college students. So as specific as possible. And then for large counts, we just need to see if all the expected counts are what? Greater than 5. Are they? Yes. So we say all expected counts are greater than 5. Anything else that we have to do for conditions? No, we're done. Okay. Next question says the table below shows each of the contributions for the chi-squared statistic. So let's say we're back on Desmos, right? They gave you our contributions, but remember, if we hit the check, the box where it says contributions, okay, it will give you the contribution for each one. You just have to click on each of the things, okay? So notice all these numbers are the same as the numbers they gave us, okay? That's just how you find it on Desmos. So it says, using this information, find the chi-square statistic and the p-value for the chi-squared test for homogeneity. Okay, we don't really need to do this by hand because we have Desmos. But since the question is asking us to do it by hand, we are going to do it by hand. Okay, we just have to know that all the contributions, if we add them all together, that is going to give us what? Chi-squared. So to show that without really showing that, right, we're going to say chi-squared is 0.79 plus 0.022 plus ... plus 1.374 is equal to, right, I'm showing that I know that I have to add everything in that table. Okay, but I'm not writing every single contribution together. That takes too much time. So once I get to that part, I'm going to go to the significance test on Desmos, and I find that my chi-squared value is what? 14.4. Okay, and then my p-value is 0.072. Okay, so if it asks you to use the contribution table to find chi-squared, show the grader that you know that means to add them together by adding a few of them together and doing ... Okay, until you get to the last one, and then just go to Desmos to get your answer. Okay, last part E, says what are the largest contribution to the chi-squared statistic and what does this mean in context of the problem? So first, looking at all the contributions, which one has the largest? Good, communication with extrovert, that's 4.111. Which one has the second largest? Engineering and extroverts of 3.165. And technically we could go on and do this forever, right? Since it doesn't specifically ask us how many to do, we're just going to use the first two largest. Okay. So first we identify them. Okay, so the largest contributions occur for engineering and communication majors who are extroverts. Okay, comparing just between those two numbers, which one had the highest, the communication or the engineering majors? The communication majors. So we're going to say that more communication majors were extroverts than expected. Okay. And then since engineering was smaller, the smaller of the two, then we would say less engineering students were extroverts than expected. Okay. Then we say this implies that a student who is extrovert does not have an impact on their college major.